we're going to be talking about adding and subtracting rational expressions. Welcome to Fremont Math Hub. With this lesson, we will successfully be able to learn how to evaluate the sum and/or difference of two rational expressions and provide an answer in the simplest possible form. What are rational expressions? Well, rational expressions are those in which they're special kinds of fractions where the numerator and denominator are both polynomials of some sort, aka it's a ratio of two polynomials, hence the term rational expressions. And they're not equations, they're expressions. So it's not like there's necessarily going to be an equal sign. They stand alone. One example is 2 over x. Another example is 3 over x plus 4. And this is a more complicated one. 5x minus 1 over x squared plus 5x minus 2. All of these are different forms. The first being one of the most simple, even though there are just a whole number present in the first and the second example, there is something in which there's a variable, a polynomial, in the denominator of both the first and second, and so that automatically makes these rational expressions. But it's the most obvious for the third. So here are some rules when it comes to adding and subtracting these expressions. They're the same as adding and subtracting fractions in the sense that the only things it is that you want to add and subtract are the numerators. The denominators will stay the same, and that's the key. The denominators absolutely have to match. Otherwise, you cannot move forward, just like when you're working with fractions. So, for example, 2 over x plus 5x over x. You can add or subtract this example because the x's match. So when you combine the two of these, well, you'll get something like this. You'll have the same denominator, okay, the x on the bottom, and you can combine the two, so you get 2 plus 5x. Now, these are not like terms. You cannot combine the 2 and 5x because it's not as if they both have a variable. So this would be the simplest format. Now, for this example here, 4 minus x over x squared minus 6x over x plus 1, this is not actually going to follow the rules. The bottoms do not match, and so we cannot move forward there. So in a case such as the one it is that we saw before, when the denominators don't match, you don't just stop there. You have to find the least common denominator, and you do it as such. In this example here, 2 over x plus 5 over x plus 1, you look to see, well, how can I find something in which I can have the denominators be the same? And one of the easiest ways it is that you can do so is just by multiplying the two denominators. So in this case, multiplying x and x plus 1, you don't even necessarily need to distribute out the answers, will give you the least common denominator. And here's another example in which it's going to be a little bit different. This one is a little more complicated. So if you look at the denominators, again, they don't match, meaning we wouldn't be able to add or subtract them. So one thing it is that you can see here is x squared minus 4. That's something with a squared, right? Versus on the right, it's x times x plus 2. If you were to distribute out what's on the right, you would end up with something that has an x squared. So thinking ahead to factoring and the different forms of factoring, it may help to factor in order to better figure out just how to find the least common denominator. And so this is what it is that we'll do. Look to both denominators. See if it's possible to factor them. The right side is fine. It doesn't need to be broken down any further. But what about the left side? The left side can be factored. It can be broken down to x plus 2 times x minus 2. And so it'll look like this. So what do they have in common? Okay, we're talking about least common denominator again. They both have in common that x plus 2. Okay, so we're going to kind of take that out. And whatever it is that's left over that not necessarily both of them have, will combine all together into one. So our LCD will not only contain x plus 2, but it will contain everything else. And so put it together, the LCD here would be x times x plus 2 times x minus 2. Okay, so now final step is going to be to actually evaluate. Let's put everything together. In this example, it is that we saw before, in which the denominators do not match, our LCD was x times x plus 1. So what do we do next with that? We have to apply this to both expressions. So we're going to multiply both of these expressions by the missing factor. Okay, so for 2 over x, for example, we're going to multiply both the top and the bottom by what's missing, the x plus 1. Okay, what you do to the top, you have to do to the bottom. And so we'll end up with this, versus on the right hand, we'll multiply the top and the bottom by x. Okay, so when we do so, we'll get these nice expressions here, and then we're clear to add. So when we add them, it'll be set up like this. Combine the denominators into one. Okay, just like that. And then we're going to see if we can simplify. So one thing that I had mentioned before is try not to distribute, especially in the case when we're talking about the denominators. But once everything's combined, then maybe try to distribute out, use the distributive property, and see if it'll help you to get everything together. So note here, if we distribute this out, we'll get 2x, and then we'll get 2 times 1. So we'll get 2x plus 2 plus 5x, and then denominator on the bottom, we can combine our like terms, which are this and this here. When we add those, that will be 7x, leave the 2 alone, and this here will be our final answer. Okay, here's one more example in which this is the case. So we have this example that we talked about before, where our LCD was this here, x times x plus 2 times x minus 2. We're going to rewrite the expressions with their denominators and apply the LCD. Okay, so remember that we had factored the x squared minus 4 before. So we're going to then fill in what it is that's missing, multiply both the top and bottom, just as shown here, and then we're going to combine everything together. In this case, we are subtracting. We're subtracting. So put everything with one denominator as shown, and then distribute out, just as we did before. So this here will be x squared minus 2x. This here will be minus 5x plus 10. Okay. Or actually, sorry, I'm jumping the gun and entirely forgetting another trick it is that we can use. Okay, so the trick it is that we can use here actually is note really quickly that there are 3 expressions here. There's this, and there's this. One thing it is that you can do as opposed to distributing, and this only depends depending on problem to problem, what like terms do you have? X minus 2, x minus 2, and x minus 2. If all of these 3 terms have something in common, and only the case if all 3 of them have something in common, you are allowed to cross them out. So this goes away, this goes away, this goes away. Everything else remains. This is the same if you have a constant. If all three of these terms had a 2 in common, you would just cross the 2 out. Okay, divide each one by 2. So what you're left over with is x minus 5 on top, and then the x times x plus 2 left over. Hi, welcome to Fremont Math Channel one more time. Thank you for your time. Goodbye.